Hello everyone, this is Vivian Chan. In this video, I'm going to explain to you HSC 2018 Mathematics Extension 2, question number 4, 5, and 6. Question 4. It asks you to find a graph which can represent the function of y equal to 1 over root x squared minus 4. In order to get the answer, we have to know the asymptotes of this function, which means we are asking ourselves, is there any discontinuous points on this graph? Or what will happen to the image of this graph when the input of x goes to very large or very small, like positive infinity or negative infinity? Obviously, you can see that the denominator of a rational function cannot be equal to 0. So x squared minus 4 cannot be equal to 0 means x cannot be equal to minus 2 and 2. Another thing is what will happen to the graph when x goes to very large value. And you can see that when x goes to large value, x squared minus 4, taking the square root is still very large. 1 over very large value goes to 0. Therefore, asymptotes of the function should be x equal to 2, minus 2, and y equal to 0, which is x equal to minus 2, x equal to 2, y equal to 0. The answer is D. Question 5 is an integration question. It gives you a curve of y equals to e to the power 3x. And this curve is rotated about a horizontal straight line y equal to minus 1. Then a solid is formed, and a question is asking for the volume of the solid from x equal to 0 to x equal to 4. The image of the solid of this curve y equal to e to the power 3x after rotated about y equal to minus 1 should be something like this. Let's try to vertically cut the solid into infinitely many discs. Let's consider one of these smaller discs. If we can be able to find the volume of each one of these small discs, and then sum up all the volumes of all these different size discs, it will become the volume of the whole solid. If the solid from 0 to 4 is divided into n different discs, and the n tends to infinity, the particular one that we are considering is the ith disc. The volume of this ith disc should be equals to pi times the radius square times the thickness of this disc, which is delta x. The radius, the blue line, back to the curve, it should be this one. It is the distance from the curve all the way to the horizontal line y equals to minus 1. And if in this particular point the x value is xi, then the function value should be e to the power 3xi. And the distance between the function value and minus 1 should be e to the power 3xi plus 1. Therefore, the volume of this particular disk should be pi times the radius square times the thickness, delta x. The volume of this solid should be the integration from 0 to 4, and the volume of each particular disk is this one. Since we are considering x from 0 to 4, we use x instead of xi. Each particular disk volume addition, integration is kind of addition from 0 to 4, add them up all together, and this pi, we can do the multiplication after the integration, so we can take it out. Integration, this is the volume of this whole solid, and the answer is A. Question number 6 is a question of complex number. The question asks for the sixth root of I. The graphical representation of I should be like this. The argument of I should be pi over 2 with the modulus equals to 1. Therefore, I can also be written as cosine pi over 2 plus I sine pi over 2. And then the sixth root. By theory, we know that this to the power 1 over 6 can be multiplied to the argument pi over 2. So the argument becomes now pi over 12. And starting from pi over 12, we divide the circle into 6 equal portions. And starting from pi over 12, the argument is increased by pi over 3 each time. And all the 6 roots are pi over 12 increased by pi over 3 each time. Increase the second time is 2 pi over 3. The third time is increased by pi. Fourth time is increased by 4 pi over 3. The fifth time is increased by 5 pi over 3. And these are all the 6 roots of I. And among the 6 of them, we can see that pi over 12 plus 2 pi over 3 should be equal to 3 pi over 4. 3 pi over 4 is a special angle, and cosine 3 pi over 4 should be equals to minus 1 over root 2, and sine 3 pi over 4 should be equals to 1 over root 2, and the answer is therefore A.